One of the things that I want to talk about is the architecture. As we've already said, we request an outcome through either the navigator or the API, and the navigator is just a way we express the API. We then have within that a number of automation jobs that define how we get from point A to point B, and the service, and within that we make intelligent decisions about which one of those automation tasks we will run to get you through the various iterative steps to get you to that outcome at the end. So within inside that controller, it's run as a collation of these automation jobs built in as Trey mentioned, a containerized management plane environment. There are a couple of VMs in there, but our goal is to have a fully containerized environment. And that's what allows us to have the dynamic scaling of the management plane. As the systems get larger, we can add more and more nodes without compromising the performance of this automation scope. And again, the key strength of this is that we are applying a layer of automation over the technologies that already exist. We are not creating something new that makes them irrelevant. We're just giving them a more optimal way to get to an outcome by sequencing that chain of events through these automation jobs.
The design center, when I was talking to the developers, which by the way, I should mention this because I don't give this enough press. When we built this team in a matter of 7 to 8 months over the course of 2 years, and 40% of our software development team is actually female. So when we talk about those diversity and inclusion goals, this team is very diverse. It's a global team, very young, and very seasoned in open source technology. I think when we get to the slide where you actually see the open source stack that we've built here, you hopefully see the design intent that we intend for this to be applicable in many different use cases, many different environments. And the design center that I drove with these folks is, any of you have bought a new phone these days, you got your old phone and the new phone, you put it next to it within Bluetooth range, and all of a sudden you say, hey, there's a new phone there. Would you like me to install it for you? And copy all the information over from your old phone. We're trying to make the consumption of our infrastructure so easy that it becomes an infrastructure as a service. And this is a small step on the journey to get.
So in that sense, then, you must see yourselves having to go up and compete against things like AWS Outposts or Azure Stack with Arc and so on and so forth. Those sort of hybrid cloud play pieces.
I think if those natural competition emerges, that's fine. Our real focus is helping the customers that buy the billions of dollars of our storage arrays and servers very easy for them to deploy, because they're going to continue to make those investments. And if we forego an investment in Amazon or whatever because we're easy, that's great. But it's not, there's plenty of opportunity for us to focus on making the existing customer base.
I think one of the other key things there with those alternative kind of on-prem offers that you mentioned there is that demands some operational change from the customer to be mandated. If they want to move from running it today to running it on a Azure Stack or Outpost, they have to take the business operation they're running today, not just the technology, but all of the business processes that surround it, re-platform it to run in DynamoDB or whatever the version of that they're landing it to. And it requires a big cultural and operational change in the business. What we're doing is we can take existing mission-critical applications as they're running today on compute, network, and storage, re-platform it to a modern architecture, keep their operations, keep their applications exactly the same way they are today, and then when the customer is ready, they can onboard and take this automation to streamline their existing day-to-day tasks that they're already doing today, and just give them a better way to get to that outcome.
You'd start that streamlining and then maybe look to Project Pacific to then start breaking the application up from the monolith, and then decide where best to go.
As the owner of the product management team, I would love everybody to take PowerOne and automate everything. Day one out of the box and just use CRGs in the right. That's not what IT transformation is about. It's about giving people a progressive route to take what they're doing today, to modernize the operational process, and then ultimately through software help them get to their stated business transformation.
Do customers get to tailor the memory, number of servers, number of storage, number of SSDs, SCMs, all those things?
They get to tailor everything.
So within a PowerOne pod, they can pretty much configure it how they want.
Yeah, in the MX7000, there's multiple server choices. There's any number of memory combinations, whatever they want. Within a PowerMax, it's any particular PowerMax configuration they want to deploy, from 2-engine all the way up to 8-engine, and whatever disk drive type they like.
Right.
So you mentioned you want to help people adopt the storage, and you said I think Unity's coming later on, and we're going to see other flavors as well appear down the roadmap?
Yes. Okay. So it's a big importance for us. I would say in FY21, the most important thing is expanding the reach of PowerOne. And so the primary area there was mid-range storage introduction and rack server introduction, because there are a lot of people that deploy rack servers instead of modular blade servers, and we want to expand that market opportunity for those. So those are the big ticket items that we're focused on in this fiscal year.
Just one last thing to touch on this. I get asked quite often, can I insert my own automation jobs in there? Can I have this automate something else? That's not really the intent of the PowerOne Automation. We're about that southbound API control to use all of those resources to abstract and create a CRG, and then have this driven by some external automation. We talk to a lot of customers who have a very prescriptive approach to data center automation they're deploying today, whether it's Terraform, Ansible, whatever they've chosen. The goal here is to make the PowerOne system consumable through software. And as I say, that's not an immediate day one big bang approach. They can take it as a modern infrastructure platform and gradually evolve their operations to leverage the automation when their operations teams are ready.
Controller architecture, we covered this pretty good.
Yeah.
Let's keep going so we can get to some other stuff and then do.
We spoke about the we
covered that.
Yeah.
And this is more detailed steps of some of the things that we're. You can click through this pretty quick. So launch assist, we covered this inventory inspection. There's infrastructure reachability examination. There's firmware.
This was the demo.
Repeat of all those steps that were. By the way, our automation on the server front is using embedded OME and iDRAC automation. We're using, and when we use iDRAC, we're using Redfish APIs, if you're curious about that sort of stuff. And then we're leveraging the native APIs in PowerMax, in Ansible, kind of plugins and modules there.
Right.
Keep going with this management network. Let's just breeze this. They've already seen this, so.
And it happens that fast, doesn't it?
Yeah,
pretty much.
4 hours.
Yeah,
pretty much.
It's
No, it's a 4-hour endeavor.
The stages of automation.
Yeah.
That was unboxing, but that's done once when you get it. This next stuff is the consumption of infrastructure and the operationalization of that.
It's like when you buy a new fridge or a new dishwasher or whatever, you do have to set it up once. But after that, what you've actually bought it to do is the main
and the
challenge.
problem with the unboxing experience with these technologies, they're done so infrequently that customers end up unboxing equipment with different best practices, with different deployment standards. And as they do that, they have different scalability limits. This is about enabling a customer to programmatically repeat the unboxing experience in a very standard way that's best practice from the company that manufactured the equipment. So there's an important outcome from that in itself.
Right. We mentioned the Lifecycle Assistant. Again, part of the value is we abstract a lot of the complexity of all these tasks that are going on. But I think it's important that, especially for this audience, we just sort of expose all of these steps. These are the automation steps that I'm talking about, that we make intelligent decisions about running, whether it's inventory in the system, whether we're doing particular versions of firmware that Trey mentioned that we've blacklisted, that we've detected on the system. Again, here, the objective is not to lock the customer's operations out. It's about to keep them within the safety guardrails about what we know are good configurations, and then how we've used those configurations to build these automated outcomes.
By the way, one of the benefits of the state engine functionality that runs as a microservice in the controller is actually not taking a draconian approach to say, hey, this release of firmware is bad, but actually going the next step to say this particular configuration when employed, when this firmware is present, is bad. So if we can advise you to modify or adapt a configuration, but still run a version of firmware, that's a more autonomous outcome than just saying, don't run this particular version of software.
Yeah, and the key thing is it comes back to it's contextual based on the use case. As Trey said, a particular version of firmware on one blade might be fine if you're running a particular version of vSphere, but it might be a big no-no if we know you're running that version of vSphere with vVols or a particular version of VROP. So that contextual use case is we don't just have one standard, we have multiple standards, and as part of the evolution of our understanding of these best practices, we add Pacific and all those other platforms, we'll continually evolve and maintain those standards, not just for one product like the servers, but the server, the storage, and the networking that connects it all as well.
And by the way, the slide says compliance scanning. It is best practice compliance. It's not any sort of regulatory compliance scanning, as I assume you would assume, but I wanted to make
But on that note, is there like equivalents like a co-pilot or something like that where you can go in as a vendor and verify things and check things out? And
yes, all of that information can be pulled programmatically through the API. So you could create some query externally in a NOC to be able to say, is our systems in configuration compliance? And
you can see drift.
Yep, absolutely.
Yep. And part of the value of the automation is if we deploy it with a set of known standards, and then there is some, let's put it politely, human intervention in that after we've deployed it, we can call that out that it's configuration drift away from the standards. It might not be a life or death event, but again, within the boundaries of the rules of the road, as it were, of what our automation understands is a known good configuration.
But also, more importantly, allow configuration drift. Yeah. You may decide as a business you want to run this release combination, and you're accepting those risks of that integration, and you want the autonomous control to be turned off. It's perfectly reasonable to do that.
The Lifecycle Assist, I'm assuming, dials home to get the configuration best practices. Would that be right?
Through that link to the SRS and support assist, yes.
What about for sites that aren't allowed to dial home or?
There's a jump box on the VM that runs on the system, and a service technician would need to look at that jump box or make an API query internally in their secure environment. But all possibilities are, if they're disconnected from the world, then somebody has to do it locally.
There's a way you could download it and walk it in.
There's an offline, dark site ability.
Sneaker net.
Yeah. But the key thing, again, when we talk about system updates, we're not talking about patching one individual component. We're talking about how do I patch this abstract construct called a CRG. And that might be, I'm running vSphere 6.7 and I want to go to vSphere 6.7 update 3. We know as part of that lifecycle update, there are not only software changes, but there are a cascade of potential hardware updates required downstream, whether it's on a hardware compatibility list on a server, whether it's some component on the storage array. So wherever we can, we automate the wrapping of those system updates into an update package. And we update at the CRG level, and as part of that intelligent rule-based decision-making, we will call the individual automation steps to either patch the firmware on the blade, to ultimately getting the infrastructure prepared and then deploying the update to the hypervisor.
What happens if there's a requirement to physically change a piece of the infrastructure?
Then as part of our system standards, we would call that out and say, it's almost a kind of what-if scenario. So as part of that upgrade, we assess as to whether we're going to have to upgrade some of the components or whether we just don't have the components suitable to land that ultimate platform on there.
Also, these configurations are backed up, so if you lost a top-of-rack switch or something like that, one of the other things that we've embedded and we don't talk about because it's not that sexy is there's a terminal server that ships with this. And so we can actually get to hardware-level diagnosis programmatically of understanding what state a device is in, and we can recover the configuration state of that device once the equipment is replaced. So you actually get to roll back to the last known good configuration state of that particular configured device.
Where is that stored?
That is stored in the controller, and we have PowerProtect software that runs where you can serve out a LUN, or you can have PowerProtect load this into whatever data protection environment the customer has.
The last step to talk about in the controller is the third step we mentioned, expansion assistant. And again here, the consumption is at the cluster resource group level. where I've created this high-level object called a compute network and storage running a platform, and now as the workload increases or the business demand changes, I can increase and scale that, assuming I have the physical components available in the infrastructure. But again, through a single declarative API interface, I can ask the system to expand or contract the resources which are made available to that resource group. Again, to try and think about this in a practical construct, if I have an existing vSphere cluster which is running on some blades and some storage, through a single API interface, I can ask for that cluster to be expanded, whether it's adding servers, whether it's adding storage, and it will not only automate the preparation and the provisioning of that infrastructure, but it will also apply all the relevant changes into the virtual infrastructure up through vSphere as well.
Go ahead.
Can I share storage out from my Macs to that existing cluster?
Can you share storage out from?
Our Macs to that existing cluster?
You can, yes, absolutely. You can. Another thing is you can also delete clusters. But one of the things that we wrote into the software is we will not delete the storage. So we will clean up the SAN fabric, but we won't delete the storage. You will have to go into the PowerMax and say, destroy that data.
I really don't want to.
We do not want to enable the ability to lose the data, but we do want to clean up the infrastructure when something is deleted. There's a lot of bits of things that are left around when you build a cluster, and we want to enable a clean sweep of that.
So, again, we've discussed a lot. So in terms of how we integrate with vSphere, and I'm just watching the clock, I'm going to try and explain at a very high level how this architecture hangs together, and then we can pass it over to David, and you can see it in real terms. So we have this concept called a CRG, which is what we use to build vSphere clusters, this aggregation of compute and storage intelligently connected through networking, onto which we will deploy a vSphere platform. That we attach to the platform controller that you saw deployed at the beginning, which is the kind of workload vCenter. And through that, then, we continually monitor both the state of the virtual and the physical assets and feed that back into the PowerOne controller. Now, the customer is then free to consume that as they would in any traditional VMware environment, deploying virtual machines. Again, we monitor and we assess the continual state of that and whether we're deleting clusters and CRGs. Through this. Oops. There we go. One too many. So the point is, this gives you this repetitive consumption model of a CRG by carving up the infrastructure. Not, I want some storage and I want some blades, I'm going to find a way to bind them together. The purpose of the automation through this ongoing consumption is this is how IT operations is done now within the business for deploying virtualized clusters. We not only maintain the infrastructure asset, we deploy the software asset and provide this continual contextual awareness of the state of the system, but also provide the automation to maintain the state of that infrastructure as well.
What's the difference between the blue and the green boxes?
The blue boxes are the infrastructure automation that the controller is executing. The green is another automation. In this example, we've used VRA, VRO to deploy the virtual machines in the environment. It could be SCDC manager to provision, to manage hybrid cloud resources on and off premise in the environment. So the idea here is that the art is meant to illustrate that this works. It does infrastructure automation and works in concert with other layers of automation.
But is that included within PowerOne, or is that an add-on?
So it is included in PowerOne, assuming you're licensed for it. So it's there. You know, yeah. Most customers that deploy VMware environments have ELAs, and they have all of that typically included. We're typically not selling the VMware licenses with this offer. They already have VMware licensing, but we can sell the VMware licensing if they need to. But
I think that the key message from this slide is, despite all of the complexity of these infrastructure components over here on the right, there are only real 2 points of interface for the customer. One is through the highly autonomous software that's deploying and managing the underlying infrastructure components, and then through the general business operations through the vCenter tooling as well. So again, it's about abstracting the complexity of all of these interconnected components of infrastructure, logically carving them up into these consumable units called systems, and then using that to present back to the traditional operations plane how this resource can be consumed as a vCenter form. It's a question.
If vCenter wants to make changes to things like networking, for instance, will it have to talk to the PowerOne controller to do that, or does it just talk directly to the host that it's sitting on?
We have a neat way of solving that. So we actually have a plugin that lives in vCenter. So if you create something like an additional port group, that through the component we call Omni, that's the brand name for it, will trigger that networking change event going through vCenter. It will then talk through the infrastructure to the blades and the servers that have been identified as part of that vSphere cluster, and it will selectively expose those port groups and those VLANs uniquely to those servers.
It'll upgrade the server templates. It'll apply the VLAN mappings to the egress and ingress ports if necessary. It'll apply in the spine and leaf architecture all the necessary VLAN mappings. So that's, again, from a VMware perspective, you define what you want, and the Omni plugin will execute all the logical configuration in the network fabric that's in PowerOne.
Assuming then that's the same with, say, NSX. They started playing around with that for.
So part of that linkage is actually with NSX and Omni as well. So.
And the important thing about that is if you look at, again, how people traditionally would do that, especially in a large-scale complex system, they just expose that new VLAN to all of the servers because it's difficult to find out which. Yeah. So not only are we automating the deployment of that, we're actually being more secure by selectively exposing it just to the CRG that needs to see that port group. So again, the focus of the automation is to improve both the efficiency but also to reduce the risk.
So before we do the demo, can we show them the stack, the software stack? I'm not sure where that slide is. So there's a lot of stuff running in this architecture. It was built with CentOS. It runs GlusterFS as a software-defined storage layer. We use Hiketi to be an API-driven RESTful API for dynamically configuring the software-defined storage layer. We use KVM to manage the environment, and OpenNebula then to manage that virtualization environment that goes across there. We run virtual machines as well as Kubernetes to run the various microservices in the architecture. So
the architecture is KVM, the virtual machines are KVM and not VMware?
Yes, because we want to be able to support outcomes other than VMware.
From day one, it's only VMware, but moving forward, they said they're going to offer others. So yeah.
Well, this is your controller. This is your control plane, right?
This is
This
platform
is the
independent.
control plane. I'm
Yeah,
using
that's
it.
what I'm saying.
It's kind of, okay.
Yeah, because there's licensing involved, so.
This is an open source stack that we manage, and the idea here is to be able to support infrastructure automation for any configuration outcome, not exclusively just VMware, which is another neat. People use our external storage arrays for running other environments. They deploy our servers to run other environments. We want to be able to automate those outcomes.
So I think one of the ways we describe it is this automation, this management plane presents infrastructure to VMware as opposed to presenting it through the VMware provisioning tools.
Understand also, to run the VMware automation tools, you need to have VMware installed. And so we needed to build a stack that required 0 human hands to install itself. So when an order is placed in our factory, this stack is dynamically built with customer information and deployed to the controlling engines from the order that's processed in the factory. No person installs this. This is installed by automation software in our factory.